Good morning, and today we're going to be continuing our derivative series, and today we're going to be looking at the derivative of cos x. So let's say that f of x this week is equal to cos x, if I can actually write that, then f dash of x will be equal to cos of x plus h for some small h, minus cos x, over h, and this is the limit as h tends to 0. And that is equal to, we're going to use so I'm going to write the limit first. Limit as h tends to 0. We're going to use the double angle formulae to remember the multiple angles, but the easiest way to remember these, I find, I'm just going to write a little note here, so a little star. Sine of 2x is equal to sine x, 2 sine x cos x. And therefore you can split that up as sine x cos x plus sine x cos x. And that's how I remember the sine one. The cos one is cos squared x minus sine squared x is equal to cos 2x. And so what this helps you remember is that cos x times cos x minus sine x times sine x. And that's just how you remember the form, or at least how I've remembered it. I hope that helps. So that's my little note. I'm going to draw a little red box around it, being careful not to ruin any of the other work. Cool. Okay, so we're going to continue this over here. So the limit, actually no, we don't need to, we can just continue that line. So cos x plus h, using our form that we've just written, will be cos x times cos h minus sine x sine h minus cos x all over h. And that will be equal to, I'm sorry my equal signs aren't aligned, but hey ho, that will be equal to the limit as h tends to 0. I'm going to evaluate what some of these things will be when h becomes small. So cos h will become 1 minus h squared over 2, which is so cos x times 1 minus h squared over 2. That 1 here will actually cancel with this cos x here. So we'll deal with that in a minute. Minus sine x times h, because sine h tends to h when h becomes small, minus cos x all over h. Now, so I'm going to cancel this, I'm going to do it in red. I'm going to cancel this cos x with this cos x here, and therefore, and also this h will be cancelled with this h here. So the next line I'm going to write is the limit as h tends to 0 of cos x times minus h squared over 2 minus sine x h all over h. And this is where I'm going to cancel my h's. So 1, 2, I've taken out a factor of h, and therefore I've cancelled with the bottom. I'm going to make that smaller. And so that will be equal to, if I do my limit, to minus sine x, which is the derivative of cos x. So little square. And thank you for attending this video, and I will see you all next week.